Okay, guys, so I can't be here today because Sophie has a doctor's appointment. But I really don't want to lose a class since we are getting very close to the departmental now. So it's important that that you use this time wisely and that you actually listen and try to learn the information I'm trying to give you. So keep notes, please. Okay. So I'm just going to go through the slides that I would have done today in class. So we're going to be looking at exploring the graphs of periodic functions. So you're going to have to learn a bunch of characteristics of these graphs, just like we did for logarithms and exponential functions. There's a little bit more to sinusoidal functions, so you're going to have to learn a number of different things about them and about how it works. Okay? So first of all, a periodic function is a function whose graph repeats in regular intervals or cycles. So if you look at this picture down below, if you look at the picture there, that picture, you can see what a periodic function means. Is that function is going to keep going up and down, up and down, up and down forever. Okay, so this is actually a very, very basic trigonometric function or periodic function. Sometimes periodic functions are called trigonometric functions. There's other functions that are periodic that aren't trigonometric, but the ones we're going to be looking at will be. So sometimes they're called sinusoidal functions, which is just a really fancy word that means involving sine or cosine. Sometimes they are called trigonometric because they have trig ratios in them, but don't worry too much about the terminology. Just we know we're going to be seeing these graphs that are like waves that keep repeating forever. Now, here's the first word you need to know, and you need to know all these words because you're going to be asked them on the test, and you're going to be asked to identify these characteristics of graphs. So the first one we're looking at here is midline. So that's the line halfway between the minimum and maximum values of a periodic function. So you can see there, here the midline is the same as the x-axis, okay? That midline right there, yeah, I'm drawing on it there. That midline is just the same as the x-axis. Now that's not always going to be the case, right? Like if you have a graph where, if we had a graph where the minimum and the maximum were not right around the x-axis, the midline is still just going to be right in the middle. Okay, so the midline is whatever value is right in the middle between the minimum and the maximum. So that one, I don't know if we made up the situation, that could be 4. Okay, we might say that the midline is y equals 4. Okay. Here I would say the midline is y equals 0 because it's right on the x-axis, which is the same as y equals 0. So remember, it's y equals because we're talking about a height, okay, right? It's a height of 4, and y always represents height. Okay, so that's midline. It's just the middle between the maximum and the minimum. Now there is a pretty easy calculation to figure that out. It's look at the maximum. So the maximum is 2. Okay, and the minimum down here is -2. Now, if you want to find the middle between those two values, what you do is you do the max plus the minimum divided by 2. So here it'd be 2 plus -2 divided by 2, which if I type it in, it gives me 0. Okay, so it's a pretty easy equation to use. Okay, or a way to figure it out if it's not just obvious to you. Because sometimes it could be a decimal or something. When it's a whole number, it's pretty obvious, but sometimes it's not. Okay, so now some of the other words. The amplitude is the distance from the midline to either the maximum or minimum value of the periodic function. So that basically means it's the distance from that midline up to the top. Okay, so it's half, really the way to think about it is it's half the distance from the minimum to max. Okay, so a formula to figure out that one, and you don't want to mix these two things up, but a formula that you could use to figure that out is max minus the min divide by 2. So in this example on the left, because remember the max was 2, the minimum was -2, so I subtract -2, divide by 2, I get 2. Okay, so the amplitude here is 2, but of course I could also just count. Okay, it's just 1, 2. Okay, 1, 2. So it's just that height. Okay, the amplitude is the height of the graph, but it's from the midline, not from the bottom to the top. Okay, and then the period now, finally, the period is the length of the interval to complete one cycle. Okay, so how long does it take to go all the way up, all the way down, and then to be back at the start? Okay, so it has to be one total cycle. So here, if I look at this, if I'm just counting on this example here on the right, if I'm just looking at this example and I'm just counting, it looks like the period is just, if this is just a scale of 1, is 1, 2, 3, 4, 5, 6. Okay, so it looks like it's 6. Okay, here the period is 6. So it's just however long it takes to go all the way up, all the way down, and back. You know, right back to where it started again. Okay, so let's try drawing the graph for y equals sine x. Okay, since x represents the angle, the values on our x-axis here, you can see them. I usually have a discussion about it, but I'll just tell you. The values are angles, right? I'm going up by 30s here, which is pretty reasonable, I think. You could have maybe gone up by 45s or something, or even 90s if you wanted to, but I'm going to go up by 30s. Now, this is the most basic periodic function that we're going to be looking at, sine x. So you want to be really familiar with what this looks like at the end. Now, the way we're going to figure it out exactly is we're just going to type some values into our calculator. So if I type sine 30 into my calculator, and if I type sine 30 into my calculator, what do I get is the question. Okay, so try it right now. Try typing sine 30, and I'm going to wait. Whoever is there with you is just going to stare at you awkwardly until you type it in. Okay, so type in sine 30 into your calculator. Make sure your calculator is in degrees if it's not already. So if your calculator wasn't already in degrees, put it into degree mode. To do that, you go into mode, and you press degrees, not radians. We are going to have to go back and forth. And now, if you do that, if you type it in and it gives you negative 0.988, it's because you're in radians. So you need to change. You need to go change into degrees. Okay. Now, so if you've typed that in, I'm hoping some of you have, okay, because I've waited long enough. The value is 0.5. Okay, so the value is 0.5. So that means it goes through 0.5 there. Oh, I guess we should have tried 0. Let's try 0 just to make sure. So try sine 0 for me. So try sine 0. Type that in. Okay, so if I type sine 0, I get 0. Okay, then I'm just going to keep going, okay? So we're going to keep trying sine 60. If I try sine 60 on my calculator, I get 0.866, so that's hard to mark, but I'll just mark it somewhere around there. Now 90, if I do 90, I get 1. Okay, 1, that's a nice whole number. Okay, then sine 120, so if I go 120 sine, I get 0.866 again. Okay, so that's like symmetric. Okay, if I go 150 sine, I get 0.5 again. And you can kind of start to see what's happening here, right? 180 is going to be 0. Now, there, we wonder what's going to happen. And spoiler alert, is going to go down into the negatives. Okay, so if we take the sine of negative 210, I get negative 0.5. Okay, and I bet I'm going to get negative 8.66, negative 1, 0.866, negative 0.5, 0. And it's just going to keep going like that, right? And it's going to be a little messy because I'm doing this on my computer, but you get the idea. So if I'm drawing the graph, okay, the graph looks like that. That's pretty good using my finger here on my iPad. Okay, so the graph is periodic. We can see it's going up and then down and then up, and it's going to keep going like that. It's going to keep going up and down forever. Okay, so the midline of this graph, okay, let's talk about some of the details of this graph. The midline of this graph is right in the middle, is the x-axis again. So what do we write? Y equals 0. Okay, that's how you write x-axis. Okay, now the amplitude. The amplitude's the distance between the midline and the top. Okay, so that height is pretty clearly 1. Okay, and now the period is the amount of time it takes, or in this case, it's the number of degrees it takes for it to start at the bottom, or actually it doesn't start at the bottom here, it starts in the middle, but start at the middle, go all the way up, go all the way down, and get back to where I started. And it's 360 degrees. Which actually, if you think about it, makes a lot of sense, because 360 degrees is a circle. So when we're looking at sine x, we're looking at the amount of time it takes to go in the whole circle. Okay, so it's 360 degrees. We consider that sort of like the basic period of just a simple periodic function. Okay, so this is what sine x looks like. Now, guess what we're going to do next? Okay, it's going to shock you, but we're going to look at cosine x. Okay, so make sure you're writing this in, because you need to know these graphs by heart. Okay, it's really important that you know these graphs. At least, I know you can always graph them on the calculator to take a look at them, but you should be really, really familiar with them. Okay, so now if we do this one, if I type into my calculator cosine 0, okay, now remember sine 0 was 0, and that's why we started at 0 there. We started at a height of 0, right in the middle of the graph. Now cosine is going to be different, so try it out, cosine 0, let's try it out. And I type it into my calculator, and it actually gives me 1. Okay, so cosine's a little different. It doesn't start down at 0, it doesn't start at the origin. Okay, it starts at 1. It starts at what we will notice soon is the maximum. So then if I type cosine 30 in, I get 0.866. I get that value that I was getting before. Okay. If I try cosine 60, I get 0.5. Okay. I try cosine 90. I get 0. Yeah, and then it's going to keep going. It's going to keep going the exact same way. So it's going to be 0.5. 0.866, negative 1, 0.866, negative 0.5, 0, 0.5, 0.866, 1, 0.866, 0.5, 0, negative 0.5, negative 0.866. Okay, so that's what it's going to be if we just kept typing in the values. But you can, once you start, it kind of becomes obvious. So if I am graphing it, it's going to look something, ooh, that one's a little messy, that's okay though, like that. Okay, so you can see here it's still going up and down forever and ever, exact same way as sine, but it starts in a different place. That's what's most important about it. So it's remembering that sine starts at the origin, cosine starts at the top, or at 1. Okay, so they start in different places, and that's what's important about them to know, that cosine starts at the maximum, sine starts at the middle. Now the midline here, the middle of the graph, is still the x-axis, so it's still y equals 0. It's exactly the same. And the amplitude even, because the amplitude, if I look from the midline up to the top, it's still 1. And the period now. So now, remember with period, it's important because it's how long it takes to do a complete cycle. So to get back to where it started. So when we looked at sine, we started in the middle, we went all the way up, we went all the way down, and then back to the middle. Now here, when I'm looking at cosine, that's not how I'm looking at it. It starts up at the top. So I'm looking at how long it takes to get back to the top. So if I'm tracing here, I'm like, okay, it's at the top. It goes down, 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 down. Okay, now it's going back up, 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 and now it's back to the top. Okay, it goes through the top again at 360. So the period is still 360. It looks a little bit different. You can start from anywhere. If I start even at the bottom, like say I decide to start here at the bottom, and I just would have to go up, 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 and then back down. And where it meets the bottom again, that difference would give me my period. So it's how long does it take to get back to where it started. Okay, a little repetitive here, but I do need to show you it with radians. So remember, just like yesterday we learned, right, that in a circle there are 2 pi radians. Remember we talked about y and everything, but that's all you have to know, is that a full circle is 2 pi. So remember, 2 pi is the same as 360 degrees. And remember when we looked at sine, 360 degrees was the period, remember, 360? Okay, so that's the same as 2 pi. So remember, sine starts at 0, 0. Now, to figure out these values, what you have to do is you have to change your calculator into radians. So you have to be really comfortable switching back and forth in this unit. Hopefully there's someone around you, if you don't know how already, who can show you how, because you're going to have to switch to radians here. So switch your calculator to radians and try typing in sine pi. Okay? So if I type in sine pi, I get 0. That's kind of funny. If I type in sine 2 pi, if I type in sine 2 pi here, I get 0. Okay, they're all 0. That seems weird. Okay, so what happens in between? Well, it's the same as what happened in my last sine graph. It goes all the way up and all the way down. Okay, and then back to the beginning again. So where is that maximum going to happen here? It's going to happen halfway between 0 and pi. So it's going to happen here. Now, what's that value? Okay, what is that value halfway between 0 and pi? Some of you guys, I'm sure, know because you were saying it yesterday when we were looking at radians for the first time. Halfway between 0 and pi, remember if 2 pi is 360, pi is 180. Then it's a lot easier. Then we all know, oh, it's 90. Half of 180 is 90. Okay, but remember, if 2 pi is a full circle, then what's a quarter of a circle? And the easy thing to say, or the easy mistake to make, is to say a quarter pi, but that's not true. It's half of pi, because it's halfway between 0 and pi. It's pi over 2. So if you type into your calculator sine pi over 2, you'll get 1, because that's the maximum. Okay, and 3 pi over 2, which is right here, don't even worry about that, but that is 3 pi over 2, will be at -1. And it'll just keep going like that. It's just a pattern, right? That's what periodic means. It means that it's going to follow a nice pattern forever. Okay, so it's going to go up and down forever and ever. Okay, so it's going to look like that. Okay, and so all this information stays exactly the same. It's still y equals 0. It still has an amplitude of 1. The only difference would be the period, because you're going to use whatever notation or whatever units are being used in the problem. So here it's 2 pi, not 360 really. I know that they're equivalent, but you would use the one that the question's using. Okay, now I don't want to spend too much time on it because I'm sure you guys are bored of looking at these things, but same way, okay, cosine, remember it started up at 1. Now let's just figure out really fast, cosine pi, what's the value of cosine pi? If I just type that in to my calculator, what do you get? And if I type it in here, I get -1. Okay, so these values now, and it's going to keep going like that. It's going to be 1, -1, -1, +1, right? Now, halfway in between them is going to be the 0. Okay, the x-intercept. Okay, those are the x-intercepts. So those are at pi over 2, 3 pi over 2, 5 pi over 2, etc. Okay, so this graph is going to look like that. Okay, so draw it in, please. The midline, again, is y equals 0. The amplitude's 1. The period is 2 pi. Okay, because top to top, if I look from top to top, it is 2 pi. It's a distance of 2 pi. Okay, so this graph, cosine, sine, radians, degrees, you should be really, really familiar with them. And you need to know right off the bat, sine is a graph that starts at 0, right at the midline. It goes up, it comes down, it's back to the beginning, 360 degrees, or 2 pi later. Cosine starts at the top, gets down to the bottom, up to the top again, 2 pi later. And you really have to be familiar. Okay, so here's just a summary. You can see both graphs there. You can see that they both have a period of 360. You can see how they look when they're together. They look kind of weird when there's two of them together. So don't let it freak you out too much. Now, the scale that was used down here is kind of stupid, to be honest, but it's what was in the book. So I would prefer you guys to use something like pi over 2, but that's okay. Okay. Now, I am going to just do like 2 examples, and then you're going to have some time to practice. And you really have to try today. I know it's hard when I'm not there, but you have to give it a good shot to do your best here. Okay. So The graph of a sinusoidal function is shown below. So this is a sinusoidal function. Again, that's just another word for periodic. Describe the graph by determining its range, the equation of its midline, its amplitude, and its period. Okay, so we need to find 4 different things there. Now the range means range the same way that we've seen range be used in other parts of this course. So it's talking about the y values of this graph. Okay. Now a lot of the time our range has been y can be anything, go from negative infinity to positive infinity. But here, that's really not the case. Okay? Here we're looking at a situation where this graph has a top and a bottom. So there's a really specific way you write range, and it's always the same now, depending on what method you use. So there's 2 different methods we use. There's the interval notation and the set notation, and they're both fine. So if you're using set notation, the way it works is you put your curly bracket, you put y such that, the whole thing that you've been doing all semester. Okay? And you put the minimum value first. So the minimum value of this graph, okay, the minimum value is down here. It's -3. So I put -3. Then I put less than or equal to. Y is less than or equal to. Okay? And then I put the maximum value, which in this case is 7. And you should write YER after. Okay, so always the same. It's always the minimum and the maximum. Okay, and that means, what it means is that the graph goes from -3 to 7. Okay, the lowest value is -3, it goes up to 7. That y has to be between those 2 numbers, which is completely true. Okay, now in set notation, you write hard bracket -3, comma 7, hard bracket. And it's the same, it's the minimum, then the maximum. Okay, so it's really easy because it's always the same. I know it looks kind of complicated, but just think it's 100% of the time going to be that. Okay, so minimum, bracket, maximum. Okay, now midline. Okay, midline, remember I told you that there's a way to do this. Okay, it's minimum plus maximum divided by 2, or max plus min divided by 2, so max plus min divided by 2. This works 100% of the time if you can't tell. I mean, you might just look at this graph and be able to tell. It looks like, to me, it looks like it's 2. Okay, 2 looks like the middle. Be careful, be sure, right? Count. Okay, because it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's 2. But this equation always works because some people have a lot of trouble with that. So if I go 7 plus -3 divided by 2, that's 4 divided by 2 is 2. So the equation of the axis, of the midline is y equals 2. Okay, so that's what I'm looking at there for midline. Okay, now amplitude, let's see if I can move all this stuff up. Oh, I can, perfect. Okay, amplitude is the distance between the midline to the top. Okay, so I counted earlier, it's 5. I know it's 5. And don't overthink it. The max is 7, the midline is 2. That's a distance of 5, pretty clearly. But you can also use that equation. Remember, so the equation is max minus min divided by 2. So it's 7 minus -3 divided by 2, which is 5. Okay, so the amplitude is 5. Okay, but you don't need to show that work. You could have just written 5 just by looking at it. Okay, and then finally the period. The period is, I think, the hardest part usually for most people. For me too, it's the hardest. So it's because you have to look at what's happening here, and you have to look at where does it start, where does it end, what's from beginning to end, whatever here. Now, I think it's easiest to look from bottom to bottom here. Okay, so if I look at the two of the bottoms, look, there's a bottom and there's a bottom. That's a complete cycle because it goes from where it started, it's back to there, right? So if I look here, this is halfway between 120 and 240 would be 180. So that's 180. And this here is 360. So what's the length there between 180 and 360? How can I get that? I can just do a subtraction. 360 minus 180, 180. So the period of this graph is 180 degrees. Okay, so there we go. We've got them all. We've got the range is from -3 to 7. The midline is y equals 2. I'm sure people are going to ask me, is it important to put the y equals? It is. You need to put it or you're going to be losing points. Okay, the amplitude is 5, and the period is 180. The reason why the y equals is important, just so you don't think I'm just, well, maybe I am being a little picky, but it's because it's always going to say the equation of the midline. And an equation should have an equal sign in it. Okay, so the equation y equals 2 tells me it's y, it's a height, it's a up and down value of 2. Okay, so that's why it's important. Okay, so we've got all this information here. Let's look at just like it, just a different graph here. And it's in radians, so it's a little bit different. Okay, so it wants the exact same stuff. It wants the range, the equation of midline, amplitude, all that. So range. Let's do it. Okay, I'm going to do both again. Okay, so it's minimum, then maximum. So the minimum is -4. So I go y such that -4 is less than or equal to y. It's really important that it's a less than or equal to symbol. I'd say a super common mistake, putting greater than. It doesn't make sense if you put greater than. It has to be less than. Okay, and then the top is 2. Okay, and that's y-e-r. Okay, and then the range, the other way you could write it is just -4, comma 2. Okay, and you don't need both, right? You just need one or the other. Now, the great thing about doing the range is that it makes the midline easier, I think, if it's not obvious already. So I would do 2 plus -4 divided by 2 if I wanted to do it, and that's why it's nice. But I can tell where the midline is here. The midline, if I look halfway between, again, is -1. And I can count to make sure that's true, right? Like this is, if I'm just counting, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it's 6 below, 6 above. So it's it actually is a midline. So it's y equals -1 is my midline. Okay, now the amplitude, same thing. I can just count, right? Like you can use those equations, and especially if you're having trouble, use them. Okay, I always think that's important, but I can also just count. Now, be careful with your counting, because each one of these little pieces is not 1, right? They're each 0.5. So the distance between -1 and the top is not 6. It's 3, because I go 0.5, 1, 1.5, 2, 2.53. So the amplitude is actually 3, which is a little bit tricky. So be careful with that. So if you'd use the equation definitely would have worked, right? You wouldn't have that kind of problem, because you'd have 2 plus -4. Oh, sorry. My goodness. Okay, you'd actually have, 2 minus -4 divided by 2, which is 6 divided by 2, which is 3. So that the equation does work, and it can avoid making silly mistakes, but counting is also really great. Now, period, unfortunately, there's no equation for, because period, again, like I said, to me is pretty much the hardest part. Now, one way, because here we actually don't see a full cycle, it never gets back up to the top, really, the way we might want it to, which is frustrating. So one thing you can do here is you can just look at how long it takes to do half a cycle, because the distance from top to bottom, or even a quarter if you wanted, I know it gets to the midline to the top, and I can see how long that takes, but I would say I know that this from the top, oops, that's kind of messy here, sorry. I know that the distance from the top to the bottom here, I know that that distance from the top to the bottom is half. That's half a cycle. It's not a full cycle, it's half a cycle. So if I look at that, it goes from 1.25 to 3.75. Well, how far is that? So 3.75 minus 1.25, that's 2.5, is half. So the period then is equal to double that. is equal to 5. Okay, and that's 5 what? What are we talking about here when it looks like this? Okay, because the other question it was degrees. It was 180. This is 5 radians. Okay, you don't have to write in radians, remember. That's one of the difference between degrees and radians is you don't actually have to write the units. Okay, so now you're going to be given some practice, and I really suggest trying it. I know it's hard when I'm not there, but try it. Please help each other out. You know, ask someone for help if you need help. There's lots of people in the room who are very, very bright and are willing to help you. But do your best. Fill in the information just like this. So use your notes and try to do this because we, like I said, don't have tons of time left, and we wanna get through this unit. So give it a good try. I will see you guys tomorrow, and I'll be available to help with this more, and we'll focus on it, and we'll also hopefully move on a little bit, which I know is not what you want to hear, but definitely work hard today. Okay, thanks guys. Sorry I couldn't be there today. I will see you tomorrow.